big of a deal at all, okay? So, but a little bit more realistic in terms of the kind of questions that you'll actually see in the real world, right? Like, you're never going to see trinomials with a value of 1 in the real world, really. So, you'll notice here I bolded the first number here, okay? So today we're like, so far we've only seen a values of 1, right? How does the process change when the a value isn't 1, right? So you can see here I've changed it. It's now a 3. Really not that big of a deal, you'll see, okay? How would I get a 1 in front of x squared? Yeah, just divide it. Just factor it out. Okay. So your next additional step, your number 1 for this process is just factor out the common factor. Now my question next is, do you remember yesterday how I said just whatever the last term is, just throw it away until the end, right? Same thing applies for today. So actually, what you're going to do is just ignore that that's there. You're only going to factor out of the first 2 terms, okay? And then you're going to introduce the square brackets. So step 2 is I'm going to factor out the 3, right? And then I'm going to open square brackets. I'm going to write what's left. I get x squared plus 3x. Close the square brackets plus 7 on the end. Now what we'll see at the very end of this, and the reason why I'm allowed to do this, instead of pulling the 3 out of the 7 as well, is at the very end, when I'm just going to put the 3 back into the square brackets, right, in order to get a final answer. So the 7's not going to change. It's independent of the fact, like, I'm going to pull the 3 out of the 7, and then I'm going to put it back in at the end. So why bother doing it? It just makes the process more complicated. Right? So we just ignore it, carry it down the whole page, right? And now the process is the exact same. Step 3, find Z. So in this question, Z is going to be 3 divided by 2 squared, which is 1.5 squared, which off the top of my head, I don't know. It's 2.25. Okay, and then we're just going to carry, step 4 is just write it all out. 3 with the square brackets, and then we're going to go x squared plus 3x plus 2.25 minus 2.25 plus 7. Okay, so nothing's changed so far. Okay. Here's the 2.25. Here's my Z value. I add and subtract it on the inside. Exact same process. Okay. Now, I also have what we called the magic number yesterday, right? At 1.5. So then the first 3 terms condense. Remember, I'm carrying this 3 square bracket down. Okay, I'm not done with that yet. But I'm going to get x plus 1.5 squared minus 2.25 plus 7. Okay? And then I'm almost done. The last step is get rid of square brackets. Okay. Do we know how to get rid of brackets in general? Just actually just multiply. We just do what it says to do, right? So I'm just going to take the 3 here, and I've got 2 pieces here. I've got this piece here, and then that piece there. And I know I have two pieces because they're separated with a subtraction sign in the middle, right? So that 3 has to go to both those pieces, okay? But it has to stop, like it stops at the round bracket, right? Because I'm just doing one thing at a time here. So the 3 is going to go inside of the square bracket, but it's going to stop at the round one. So the next line is going to look like this, right? And basically, it's almost your final answer, right? It's 3x plus 1.5 squared. And then you got to do the distribution for the 3 on top of the negative 2.25. Because it's got to go to both pieces, right? In order to get rid of the brackets. Right, so you got to do minus 6.75. Is that going to be right? Yeah. So we're going to get minus 6.75. Right, now the brackets are gone. Plus 7. Now I'm able to combine these two terms. Okay. And then, is that going to be negative 0.25? Okay. And then you can write your therefore statement. Okay, so you could say, okay, the vertex for this particular question occurs when negative 1.5, negative 0.25. All right. Which just simply means, oh, is it opening up or down? Up. It's opening up, so again, we're just stuck with this minimum, right? So we know if it's opening up, then I get a minimum of negative 0.25 when x equals negative 1.5. Yeah.
So basically the 3 only multiplies like the y-intercept.
Yeah, you leave, so
like the only thing I need to multiply by?
the y-intercept. The y-intercept will be this. This.
0.25.
Yeah. It goes into, yeah. It's just, it floats here, right? So if you remember, y equals, this is the parabola written in vertex form, right? Okay, so it's just floating out front of the round bracket. So it tells you what your vertical, in this case, it's a vertical stretch of 3, right?
But why didn't it multiply like the 1.5 by 3? Because it's in the bracket.
It's that's why I have square brackets and round brackets. So that's what I say. When it goes in here, it stops at the round bracket, right? Because I've got the square one here, but there's only two. There's two things inside the square brackets. This is a piece. I could do it again, but it wouldn't serve a purpose, right? It just stops here because I've got the square brackets. So like in order to get rid of the square brackets, the 3 has to go in. And then if I wanted to get rid of the round brackets, I'd have to do the binomial expansion on it. So I'd have to, and then multiply. The 3 would be the last thing to go in at the very, very end because of bed mass. Right? So it's like, it's way more work and it doesn't actually do anything for you because it's going to, I don't think you get the same answer back as the original, but it wouldn't do anything for you if you put the 3 in there. And our goal is to get it into vertex form like this, so that we can read off the vertex, which we'll see today with word problems is, that's ultimately what we're trying to build towards, is solving the word problems. Okay. So a lot of this, again, is just kind of taking it at face value and just kind of following this, like in this case, a 6 or 7 step process. It's just following it to a T, because it's just a process that allows us to answer questions, right? It's very, just a method. I'm very methodical in what we're trying to do. Are we okay? I'm going to copy that down. Okay, so again, I've already done this question before, which is why I put it on the note. So if you just want to watch that question, you can scan the QR instead of flipping through the whole lesson. But again, we'll do this again. And I think this process is kind of cool because it actually, like, of all the things that you do with quadratics, there's a couple things that you ultimately want to answer with them, and it's very easy to get bogged down in all these nitty-gritties. Completing the square is one of the nitty-gritties, but it allows you to answer questions like how high did something go? What's the maximum revenue? Like it allows you to answer questions that are actually applicable to your life, and we'll see a couple of them today. Okay. So this question, same thing. Okay, first thing you want to do, remember we did up here, factor out the common factor from this one. Okay, so in this case, the 2 is common, but I'm only going to do it from the first 2 terms. Okay, so it's y equals 2. Introduce the square bracket. X squared plus 11x. Close the square bracket, minus 24. And then I go over here to the side. I'm going to find my z value. Z is equal to 11 divided by 2 squared, which is 5.5 squared, which is going to equal 30.25. Does anybody notice any cool pattern with the completing the square? I mean, aside from this, it always works. It doesn't matter what the trinomial is. It doesn't matter how ugly the numbers are. You can always complete the square and tell me how high or how much money you're going to make. Like, you can always tell me what the maximum or minimum is. It always works. Okay. The same's not true for factoring. Okay. Step 3, we're just going to rewrite everything with the plus minus z in there. Okay. And then the first 3 terms, you remember from yesterday, they condense down into what we have with the magic number, the 5.5, right? Okay. So we're going to get x that's positive, so it's plus 5.5 squared. Okay, minus 30.25 minus 24. And then I just got to distribute the 2 in. So again, I'm just getting rid of the square brackets, and it's stopping here. It's not going to touch anything inside these round brackets, because if I do, it just messes up the vertex form. Yeah.
I'm a little confused, like where the 11 came from.
The 11 is the
22.
The b value after you factor it out. So remember, I can't do anything unless this value is 1 there.
So could we divide by 4? Because it would be like 20 divided by 2. That would equal 11.
Yeah.
But then there's like a 5.5.
The 5. So then you still have to do the b divided by 2 phase. Right? So after you factor it out, the b value is 11. Then I divide it by 2 again, because that's what Z tells me to do, right? So you're almost ignoring, you ignore the fact that this is here, the whole question. This stuff is irrelevant until the very end. You're just doing you're completing the square from yesterday, irregardless of those 2 things. You're just doing it. Like the exact same process. You're ignoring everything that's outside of those square brackets until the very end. Okay. Is that okay? calculator up a little bit. I think I've done this enough times to just kind of like you ignore some of the details and just kind of like just do the process because it's all it is. It's a process. It's a 6-step process. So you just drill it. This is what it is. Not too worried about what's going on in it because it allows us to answer questions, right? Which is ultimately what we're trying to build you toward. We'll do one of those in a sec. Okay. So then the very last stage is to, okay, once I get to this stage, now the stuff outside of the square brackets becomes relevant because I can't get an answer without it, right? I got to get rid of those square brackets, so it's got to go in, right? So I'm going to get 2, right? And then that's going to be 60.5, right? So we can see I did the 2 went on to here, and then the 2 went on to there, and then the square brackets disappeared. And then I was left with the minus 24 in the end, and I can condense these two because they're like terms. And that's going to be minus 84.5. Any questions? Okay, so it's important that we just get it to look like yesterday and then do the work from yesterday and deal with the aftermath at the very end. Okay. That's the, yeah.
I got positive 5.5 for my vertex and for the pile thing.
Okay, so
is it just the opposite?
it's always the opposite, right? So if we were to do the transformations on this, how would this read? It's not. It's not reflected, so it's still opening up, right? But then on there, as I'm reading left to right, I would have vertically stretched by a factor of 2. Then I would have had to have moved left 5.5, right? So then I know if I move the graph left, then my vertex better be in the negative section of the graph, right? It's always opposite. And then the same thing, then I moved it down 84.5. So it's always odd. This is how you read the vertex. It's always opposite, right? Okay. Okay. So the goal is, and then the next question is like, there's only one more harder thing to do than the next question. Okay. Is everybody okay? We all got that copy? So if you look at the next question, this is like an intro into the word problems, but it like contextualizes or adds some layer of why we're doing what we're doing, right? So it says a firework is launched upward with an initial velocity of 49 meters per second. And then the height of the firework in meters after t seconds is modeled by that equation. Okay, it's a quadratic, it's a trinomial. You see the t squared there, you see t. If I were to graph it, I'd have t along the x-axis and I'd have h along the y-axis, right? And I could plot it. And it's going to follow some parabolic curve. Is it opening up or down? What's the sign on the a value? Yeah, Hunter. It's down this time, right? Because it's negative. We've got the negative out front. So it makes sense because if I fired a firework, is it gonna go down and then shoot up again? Is it gonna reach a minimum? No, we're gonna shoot it up and it's gonna reach a maximum and then come back down, right? So that makes sense. We're adding a context to it now, right? So the answer I get is going to be a maximum, right? A maximum of what after how much time is ultimately what we're trying to get to, right? So how high did the firework actually go? And how long did it take to get there? We're going to complete the square. And it's going to tell me the maximum height after how long. Okay? Exact same process. Okay. The first step here is though, it's kind of an extension question. It's kind of trivial, like it's a 2-mark question on a test or something like that. It's kind of a freebie, right? You could say, okay, at what height was the firework launched? Do we know?
1.5.
Yeah, yeah. Is it? What's it? Sorry. So if I plugged in, what's the like before we launched the thing and we had a stopwatch, what would be the time before I launched it? So before I even start the stopwatch, what's it saying on the screen? 0. It's saying because I haven't started it yet, right? So then it's like, okay, well, I'm gonna start stopwatch after I launch it, obviously, but at before I launched it, time 0. So if I were to plug in t equals 0 to right here and there, negative 4.9 times 0 is 0. That times 0 is 0. So the only thing left is this value right here, the y-intercept. Remember yesterday we talked about the c value? It's the y-intercept, so it's the height at which the firework was launched, right? When t equals 0. So then we know, okay, well the firework from a height of 1.5 meters, right? And then I guess if you wanted to, you could contextualize that with y equals negative 4.90 squared plus 4, I can't see anymore. Plus 49 times 0 plus 5, 1.5. Right? That's an easy question if you know the trick, right? So that's 0, that cancels out, and then the only thing you're left was 1.5. Okay? Now, here's where it gets interesting, okay? So it gets fired from 1.5 meters, and then I want to know, okay, well, what's the maximum height it reaches before it starts coming back down, or explodes, right? Because hopefully a firework doesn't come back down. It just explodes up there, right? So, we'll write out the equation. Okay, what's the first step? I can't do anything with it the way it is, right? And then, I guess, as we start to mix in different word problems, kids start figuring out, like, I don't know what to do when, right? So anytime you see the word maximum, maximum deals with the vertex. And then we know, based on the work that we've done, in order to get it into vertex form so I can read it, I have to complete the square. So if I see the word maximum in the word problem, complete the square. Every single time. No questions. Okay? So I know I have to complete the square on this. So in order to do that process, the a value has to be 1. Right now it's negative 4.9, so that's a problem. Right? So I'm going to factor it out. Okay? So I'm going to take it out and introduce the square bracket. I'm going to get t squared, and then you're going to do 49 divided by 4.9. Okay? 10. Okay. Plus 10t. Close the square bracket, minus 1.5, plus 1.5. Ignore the two things on the end and just do your completing the square inside that square bracket. Okay? So then I'm going to get the z value, and it's going to be 10 divided by 2 squared, which is 5 squared, which is 25. So then I go back to my equation. Plus 25 minus 25 plus 1.5. Okay? Condense the first 3. They condense to the next step. I'm going to get t plus 5 squared minus 25 plus 1.5. Now here's where it's important, okay? So like if I did not get rid of the square brackets, right? What's negative 25 plus 1.5? It's a negative number. Doesn't make any sense. I mean, it could make sense, but it doesn't make any sense. Like, you can reach a maximum height of negative, it doesn't make any sense. So, what's convenient, and this is how I've locked in the fact that I always remember that I have to put that number back in, because a negative multiplied by that negative makes it a positive. And then I can add the two together, because they're both positive now. So that's how I remember that this number has to go in back into both to get rid of the square brackets, right? Okay. So then let's see if I can squeeze this in here. This should have given you guys more space. So I'm going to get negative 4.9. Okay. T plus 5 squared. And then you need to do negative 4.9 multiplied by the 25. So I should get 1, and then plus 1.5 on the end, right? What do we get? Oh boy. What did we get? Did I do this question flawlessly? Let's interpret our answer here for a second, okay? So the vertex, I could say the vertex the way it is right now. I'll do it in a different color. Vertex is negative 5, 124. What's the problem with that answer? What's the x piece represent in this question? Time. So can I have negative time? Because what this is saying is my vertex is like over here somewhere, right? At negative 5. If this is t equals 0. That doesn't make any sense. How did I fire the rocket and somehow the maximum is over here?
So you just put it as positive.
You don't just put it as positive, but it is positive, and I know it's positive because it's referenced to time. That's how I caught my error, right? What did I mess up here? This should have become negative. When I factor out the negative 4.9 out of positive 49, it has to become negative 10. It's not the end of the world. The rest of the work is just fine. It just means that I'm going to have negative 10 here, which is going to become negative 5 there. Negative 5 squared is still positive 25, so the rest of the work's fine. The only thing it changes is this right here. The plus in between the 5 is going to be minus. The time one's good because if you see a negative time, it doesn't make any sense. So that's how under normal circumstances, if we'd have just done this question above, I probably would have just left that. Because it wouldn't have meant anything, right? It's just here's the maximum. Right? Just got to be a little bit careful. Right? So this has to be positive then. All these little plus signs in between have to turn into minuses. Okay? You want to take a break for a couple minutes? You can try a couple questions, and then I'll try the other two at the bottom. Okay? I'll do a separate video for those ones.